Okay, welcome back to video 3, step 3 of the hydrology tools kind of tutorial for chapter 3 of the Advanced GIS textbook. I've already started running the third step, which is flow accumulation within the hydrology toolbox. And so I've input the flow direction raster, which we are looking at on the screen here as the input variable, and the output is flow accumulation raster. And I haven't used what's called a weight raster yet. That's not required for this, but if you wanted to give different weights to different parts of the watershed in terms of modeling flow, like i.e. you know that they receive different maybe amounts of precipitation or something like that, you could use a weight raster, because this is basically kind of like just in the end telling us how much kind of approximate flow any pixel in the area receives, how many other pixels flow towards it. Output data type I specified as integer. There are other options, including float or double. If you had a really huge watershed, double is important. No, not double. Well, sorry, large integer might be important, maybe. Double is also having decimals. There's no decimal importance here because I didn't use a weight raster that might introduce decimals. Instead, what the process is doing is basically counting up. Like if we zoom in here and we know that, the color 1, which is gray, flows to the right. It's counting up, okay, that one flowed to that way, to that way. So as we go down in this gray, it's got 1, 2, 3, 4 different flow pixels. It's counting up all the pixels that flowed into it. So in the end, we get pretty big counts of pixels, but they're not going to be decimals because there's only integer values here. So that's why I chose integer, and the flow direction input type was D8. Okay, and then I ran it. It didn't take too long, but I did start it early because I was worried it would. So that's the good news. Okay, so let's see what we got with our flow accumulation raster. Oh, look at that. It's mostly looking like a black with a couple of areas of not black. Okay. And basically, yeah, it's just showing us pixels that have a lot of flow are close to white. So as we get in here, that kind of looks like a stream. But it doesn't look like there's many streams in here the way it's depicted at this moment. We can see that another set of streams goes off that way. Mostly looks black. Okay, so what we're going to do here in this step 3, other than run that flow accumulation raster, is we're going to kind of look at this flow accumulation raster a bit more, which we started to do. And then we're going to use thresholding to classify the pixels as either being a channel or not a channel, i.e. a hill slope. And then basically we're going to say, okay, this is areas of the landscape that are not channels, they're hill slopes, and this is where the channels are. We'll threshold that as a cutoff. And then we'll reclassify those pixels that are channels as such, and we'll turn it into a line feature rather than a raster. Okay, so to get us going on that, this thresholding is gonna require us to kind of visualize the landscape a little bit better. And so, the DEM can be helpful, but it'd be better to have something more visual, like a hillshade model. So first thing we'll do is we'll go back to Spatial Analyst, go to Surface. I'm going to create a hillshade from my fill DEM. Let's go with the defaults and hillshade of the fill. Go ahead and run that. Hopefully that doesn't take very long. Okay, so this will be useful to us in just a minute. So there's that hillshade. Good thing we used a projected coordinate system. Okay, so here's our Spanish Fork River. Okay, so now we're going to put that below the flow accumulation. Turn the flow accumulation on. Oh, look, there's some rivers there, kind of where it should be. Great. Okay, so we'll go into flow accumulation. We go to symbology. Right now, it's just stretched. And we can do that. We could stretch it in different ways if we wanted. Like if we wanted to see more things going on, I could do that. Um, what does that look like? Still don't look like a lot. Most things get colored kind of as like hill slope. Okay, background. You could play around with that and then maybe start to see more of the channel network. See? And so this is great, but that is not gonna cut what we need to do. So instead of stretch, we're gonna go to classify. Okay, and we're gonna actually just go to two classes, stream and not stream. Okay, and it's defaulting to some natural break in the histogram. Most things have very low flow accumulation. It defaulted to, well, it doesn't show many rivers, right? Many red pixels. Uh, it defaulted to, I don't know why there's decimals here because it's it's supposed to be integer, I thought, but it seems like it's not. Didn't listen to me. Um, Nevertheless, yeah, so it's too many. It's over like a million pixels is where it's cutting off the channels. So in the kind of write-up for the text of this chapter, I suggested that a channel tends to uh, initially around 10,000 square meters. These are 30 square meters, 30 meters, sorry, 30 meters by 30 meters, so 900 square meters per pixel. So we shouldn't need too many here. So if I go back to the classes and I say that the upper value here is 1,000. That's probably still too much. Now we have a lot of red pixels, which are channels. The yellow is the hill slopes. We actually don't want to see that, so I'm going to call that no color. Okay, so I made it transparent. So now we can see the hill shade in the background there. And you can see the channels on top of it. And to make this really obvious, I like to actually make the channels look yellow or something that really stands out. Black can work well. I like black in this case. And so the question we have to ask ourselves is, are we capturing the channels that we want to? We'll never capture all of them. Like for instance, come here, you can see a channel right there. Where would you take, how far up would you take that? It hasn't gone very far at this point. If I make this upper value 5,000, oh no, a little less, right? So if I make it less, it should go up higher. Let's make it 500. See if, yeah, now it goes higher up. Instead, if I made it 5,000, we would see less channels. If you wanted to study every small drainage basin, like these ones right here, they don't have any channels at the moment. Then we need to use a smaller value. If you're just interested in looking at the major trunk streams of the drainage basin, maybe 5,000 is a good number. Go back to say 2,000 and see what that looks like. So 2,000 captures a bit more. It doesn't do this one right here. It does give me something in these other ones. Maybe 1,000 was great. What do you think? Maybe that's a little Let's do 1500. Have a little less of these small things coming off in the valleys. I like that. So I went with a threshold of 1500 pixels before we build a channel. 1500 pixels times 900 square meters. It's pretty big drainage area. Okay, so we're not just capturing when a channel forms, we're capturing more area to only look at channels that maybe are more important. Okay, so that's our flow accumulation raster that's classified by channel being more than 1500 pixels. Hill slope less. Okay. So the next thing we do is actually something called, if we go back into hydrology tools, there's something called stream to feature. And you input a stream raster, flow direction raster, output polylines. That's where we're headed. I think that's right. So we actually want to use something outside of spatial analyst tools here, which is called, uh, uh, let's see. So it's called reclass. Yes, reclassification. So we've made a classification. So we're going to click on reclassify, and we're going to input this raster, the flow accumulation raster. And so right now we have, you see 0 to 1500 values, one classification. We could call it one. I'm actually going to call it no data. And then the rest, which is where my rivers are, could be 2, could be 1, could be anything. It's just that's a channel. Okay, doesn't really matter. It didn't keep it. Okay. And then we're going to call this, I'm going to call this channel raster. It's missing values, no data, sure. Okay, so we've taken things that have small flow accumulation pixels or area, called it no data, and then we've just got our channels. So we'll run that. It should turn this really kind of gradational flow accumulation raster into one that's just binary, channel or not channel. And color can be whatever we want. So there's my channels. Okay. So that works. So that is not a polyline, which is the next thing we want. So to get these, because these are rasters, so if we get these pixels to become lines of a channel, we need to do something else. So we can go back here. And you can do this a couple of different ways. So a lot of times I've used data management and like kind of taken, say if we go to raster, no. Sorry, conversion tools. So you could go from raster to polyline. So if we took this raster, channel raster, we can make it a polyline. It would be a line. That'd be great. But that's not the best thing to do. Actually, what we want to do is go back to hydrology tools, and we can go stream to feature. So we input this channel raster, that's our stream raster, and the flow direction raster. So that one is right down here, flow direction, Spanish Fork watershed. And we're going to output a polyline, and you can simplify the line. And what that means is it's going to like maybe smooth it or something, right? checked, the feature is weeded to reduce the number of vertices. That can be helpful. Basically, it's like it's not creating as many kind of clicks between where it's interpolating these pixels. That I like. So I'm going to simplify it. And we're going to call this streams. SF watershed, but it's more than that. Because there's other area. And the reason we're doing this stream to feature is because it's using that flow direction raster, and it's actually going to, I believe, give directionality to these channels. So if we had just used raster to polyline, we would have gotten lines, but they wouldn't know what's upstream and what's downstream. In this case, they will. So go ahead and run that. Okay, so we now have a streamline, and you can see that the streamline is here in red. If we want to be kind of a little bit more persnickety, we could say make it blue so it looks like a river, right? Get fat. Okay, so there's my blue stream, and it's sitting over the top of the channel raster, or the flow accumulation area where it's a channel. And you can see some interesting things. So that streamline doesn't always sit right on the areas that were calculated to be the pixels of the channel. So that's something to keep in mind in the next step, which is called like to calculate the watershed area above a pour point. Because basically what we're going to say is we're going to say calculate the watershed above the mouth of Spanish Fork Canyon. And so we'll pick a point and we want to know what's upstream in terms of watershed. Well, if I pick the point right here, the watershed calculation is not going to work because it's not on the area with high flow accumulation. That one is high flow. That one has probably very little flow, and it's not going to make a watershed. So when we create that pour point, we can't just think about the line. We need to think about the flow accumulation pixels. Okay, so that is the end of the third video, I believe. So next step is to make that watershed in the next video. Hopefully this is helpful.